Welcome back to the MATLAB tutorial series. Today we'll learn how MATLAB interacts with external files using commands such as open, fprintf, fread, readtable, and writetable. We'll work with TXT files, CSV files, and Excel spreadsheets. All file operations use full file paths, so you always know exactly where each file is stored. Along the way, we'll create variables like content, sample table, data, sheet data, average value, and max value to store and process the information. We start with simple text files. To create a TXT file, we use fopen with the full path, such as this one, and the write mode W. We then use fprintf to write lines into the file. After finishing, fclose closes and saves it. To read the same file, we open it again with fopen in read mode, R. fread loads the content into the variable content as characters. After closing the file, the content now holds the text we wrote. We can display it using disp. TXT files are ideal for logs, notes, and summaries. Next, we handle CSV files, simple, comma-separated tables. We first create a sample table, which contains two columns, ID and value. We write this table to a CSV file using writetable with a full file path. For example, this one for the file data.csv. Here, we also specify the delimiter parameter as semicolon, so MATLAB separates the columns with semicolons instead of commas, which can help if your data contains commas. After writing, we load the CSV using readtable into the variable data. Data is a MATLAB table that mirrors the structure of sample table. CSV files are particularly useful when you need a lightweight, universal format that works across different programs, automated workflows, or when Excel is not required. They are faster to read and write and more portable than Excel files, which makes them ideal for sharing raw data or for data processing pipelines. This example shows how MATLAB can write structured data to CSV and read it back easily while giving you control over formatting with the delimiter. Now let's work with Excel spreadsheets. We saved sample table to an Excel file named sample_data.xlsx in the same folder. To load it, we use readtable and store it in the variable sheet data. Sheet data contains the same columns as the original table, and we can treat it like any MATLAB table. Excel files are great for multi-sheet data and sharing with colleagues who use spreadsheet software. Once our CSV or Excel file is loaded, we can process the table. For example, we calculate the average and maximum of the value column from sheet data using mean and max. The results are stored in the variables avg value and max value. We also add a new column, double value, to sheet data, which doubles the original value for each row. Tables make these operations simple without needing loops. After processing, we save results in different formats. For a human-readable summary, we create a TXT file using fopen and fprintf and write avg value and max value to it. For structured results, we use writetable to save the updated table, sheet data, to both a CSV and an Excel file. All files use full file paths, so they are stored in the same folder as the original data. Finally, we save all key MATLAB variables, sheet data, avg value, and max value to a .mat file using the save command. This preserves the variables exactly as they are for later use. A quick reminder: TXT, readable logs and summaries. CSV, universal and lightweight, great for automation. Excel, multi-sheet and easy to share. MAT preserves MATLAB variables exactly, including tables and computed values. In this tutorial, we learned how to write and read TXT files using fopen, fprintf, fread, and fclose. Write and read CSV files using writetable and readtable. Handle Excel files using readtable and writetable. Process table data and compute statistics. Save results to TXT, CSV, Excel, and MAT files. These file handling skills allow MATLAB to connect with external data and create complete workflows. Thanks for watching, and I'll see you in the next tutorial.